Hello, Ambius, and welcome to the May 2022 Connection. Water continues to be the main topic in the technical presentation, but first we will look at another way water relates to health, well-being, and your safety. In many areas of North America, last June and last August were the warmest on record. And in many of those places, our colleagues were working outside for extended periods of time. If your job doesn't specifically have you working outside, you were commuting and traveling outside either on foot or in a vehicle, also in very hot conditions in many areas. Prolonged exposure to high temperatures, with or without humidity, can lead to heat illness, which can be a very serious condition and a threat to your health and safety. Heat illness will begin when the temperatures are high, usually above what you're used to, and then it is aggravated by things like humidity, lack of air movement, your physical health, the physical activity of your job, and dehydration. When your body heats up, it will try to shed that heat by increasing blood flow to the skin surface and releasing sweat to cool that skin surface. When you are heated up and sweating more than normal, you need to replace that moisture in your body by drinking more water. If you feel thirsty, it's time to stop what you're doing and drink some water. Thirst is a sign of dehydration, which is one of the first indicators of heat exhaustion, heat illness. Additional signs of heat exhaustion are feeling dizzy, heavy sweating, cool, pale, clammy skin, a rapid but weak pulse, nausea, vomiting, stomachache, and even muscle cramps. Heat exhaustion can lead to heat stress, which is a more serious condition. Indications are a throbbing headache, a lack of sweat, red, hot, dry skin, a rapid and strong pulse, nausea, vomiting, stomachache, and maybe fainting or loss of consciousness. Heat illnesses can be prevented. As with all work, apply the Rentokil start-stop rule. Don't start a job if it seems unsafe, and do stop a job if it becomes unsafe. Another way to prevent heat illness is to be well hydrated. A well-hydrated body adjusts and adapts better to hot working conditions. Working in very high heat requires very high consumption of water. Slowly consume about 32 ounces per hour just to replace the water lost by your body with the extreme sweating. Reduce the amount of sugar or caffeine that you consume. Working in high heat not only requires you to monitor the fluid you take in, it also is beneficial to your health to check the fluid that comes out of your body. The urine of a healthy person is an indicator of your hydration level. A healthy, well-hydrated person has urine that is rather clear in color or pale yellow. The darker your urine becomes, the less hydrated you are. In addition to good hydration, there are a few things that we all need to keep in mind during the heat of the summer. Be sure to use your break time. Sit down in a cool, shady area. Clear your mind and rest your body. Please be aware that certain personal things about you may reduce or prevent your ability to adapt to high heat conditions. These things might be a recent illness, a chronic medical condition, maybe what you ate or drank the night before, or even a previous heat illness. If you drive a car or a truck, here's another thing to keep in mind. On a sunny 70-degree day, your vehicle can heat up to over 100 degrees within 30 minutes. Conditions like this can also increase your need for more water consumption. A weather app for your phone can help identify when heat conditions are most stressful for you. Select one like the OSHA Heat app or WeatherCan. Look for the heat index or the feels like temperature because that takes into consideration the humidity and the wind. Ambius is in the wonderful business of bringing people and plants together. Sometimes that can be a challenge in certain weather conditions like the intense heat of summer. While we want to keep our plants well and our customers happy, it's also critical to take care of ourselves. Water helps keep both colleagues and plants healthy and well. Be sure to check with your manager if you have questions about working outside in the extreme heat.
Hello, Ambius. It is May 2022. Welcome to the technical part of our presentation today. We're going to talk today about how water moves inside of a plant and how it actually leaves the plant. It's interesting with plants that they can pull water upwards and defy gravity. And I think it would be really neat to discover how a plant actually does this. How can a plant take water up from the roots and pull it, in some cases, hundreds of feet up in the air? What we learned today we'll be able to apply to our plants, which include trees, but also smaller plants like pothos. To understand this, let's take a look at water and what water is. Water is a molecule of 3 atoms, 2 hydrogen atoms and 1 oxygen atom. They bind together like a group. So H2O, 2 hydrogens and 1 oxygen. This is what water is. And when you see today this symbol right here, the blue circle and the 2 red circles kind of looks like a Mickey Mouse. The blue is the oxygen and the 2 red circles are the 2 hydrogen atoms. So here I have different water molecules. I have 3 water molecules. And we're going to take a look at these water molecules and see how they behave around one another. To do this, I'm going to turn them upside down. Now they kind of look like rail cars in a train. And they behave and move much like train cars. They will stick together because they're attracted to one another. So water molecules like one another and they kind of stick together when they're a liquid. And when they bond together like this, not only do they stick together, but they also move together. And this is going to be really important to understand because as they move together, one molecule is going to pull another molecule and so on. And they're just going to keep pulling on each other as a group. And inside of plants, they have things that work just like straws. So straws are a way that you can move a liquid upwards. And in a plant, they too have structures that work like straws. These straws allow water to move in one direction, and it moves very effectively when it's inside of these straws. These straws of water run throughout the entire plant, starting in the roots, going into the stems, and ultimately into the leaves. Anywhere you have living tissue in a plant, you have these straws. The name of these straws is xylem. And xylem are these special tubes inside of a plant that move water and nutrients. If you're wondering what xylem look like, you can kind of see them in this image right here. This is a cross section of a ZZ leaf. And those little green dots are bundles of xylem tubes. And they're a little bit like string cheese in appearance. They're little, tiny little tubes that run up and down the inside of the plant. In general, these xylem tubes run in a vertical format so that water can go from down below and move upward and out inside of the plant. And again, all those water molecules are going to link together just like train cars, and they're all going to pull together. So now we know that water sticks together and it travels really well in these xylem tubes, but we still haven't talked about what's actually pulling it up. And to understand how it's actually being pulled upwards and defying gravity, we need to know where the water is going. Most of the water that the xylem tubes are pulling up is ultimately headed to the leaves. Some of that water is being used in the leaves for photosynthesis, and the rest is simply exiting the leaves And when the water exits the leaf, when it goes out of the leaf, it creates a pull. And that's called a transpiration pull. And that is the force that is actually pulling these columns of water up and ultimately out of the plant. When water leaves the plant, it doesn't leave as water droplets, it leaves as water vapor. And that water vapor escapes through this opening in the plant. I'm going to talk about this structure in just a minute. This process of water evaporating from the plant is called transpiration. Transpiration is when water evaporates out through the leaves of the plant, and in the process, it helps cool the plant. This special structure that I just showed you is called a stoma, and stoma is the Greek word for mouth, and it functions just like a mouth on a person. When it's open, things can travel in and out of the stoma, and when it's closed, things cannot travel out of the stoma. Here's a picture of a stoma that's relatively closed. When there's more than one stoma, we call these stomata. Sometimes you'll hear people call them the stomates. Stomates and stomata are the same thing. On most plants, the stomata are found on the undersides of the leaves. The stomata open and close depending on the environmental conditions around the plant. When it's dark out, the stomata close, and when it's bright out, the stomata open. The stomata can open and close based on the light because they have photoreceptors that detect the amount of light and will open more when there's more light. Here's what it looks like at night when the stomata are closed, and then during the daytime, they'll open back up. Likewise, if the light is low, the stomata will close, and if the light is brighter, the stomata will open more. Similar to how stomata respond to light, they can also respond to water. When there's moisture stress, the stomata will close to conserve water. And when there's no moisture stress, the stomata will open. When stomata are open, transpiration is allowed to happen and those columns of water flow throughout the plant. When the stomata are closed, transpiration stops and the water stops moving through the plant. These are actual stomata that are seen through the lens of a microscope. These are stomata on a Tradescantia leaf, and you can just barely see the stomata openings. And here it looks like they're just slightly open. If the stomata are slightly open, like here, it means that the door is cracked open and some water can transpire from the plant. Let's take a look at how an actual stoma works. Inside of a stoma is two guard cells, and these guard cells are what create the opening. They do this by ballooning up when they fill up with water. When they fill up with water, they bulge out, kind of like two sausages, and they create an opening that lets water out. The wider the opening in the stoma, the more water that's allowed to escape through the stoma. Incidentally, this same opening in the stoma is how carbon dioxide gets into the plant for photosynthesis. And it's also where plants release oxygen from photosynthesis. This is good for us because oxygen is needed by us to breathe. When it gets darker or water is less available, the stoma will close up to conserve water. The guard cells lose water, and as they do, they become flatter and the stoma is now closed. Transpiration now stops and water movement in the plant stops. And ultimately, photosynthesis also stops because water is no longer moving. This takes place at night because the light-dependent part of photosynthesis does not take place at night, and water does not need to be delivered to that part of the plant when it's dark out. When the stomata of a plant are shut, the plant is essentially inactive. And water and nutrients are no longer moving through the plant because the exit is now closed. And when the exit is closed, transpiration stops and the plant becomes inactive. When conditions get brighter and water is available, the stomata will begin to open up. The guard cells start to fill with water, and as they fill with water, they get more plump and they start to bulge outward. Most interior plants have stomata that are only partially open because we don't have a whole lot of light indoors. So this means that our stomata are probably only like this. If you're lucky and you have brighter conditions, your stomata will open up more, and this means that more transpiration will take place, more photosynthesis will take place, and water is going to be consumed much faster. Where our plants are grown in Florida and they're actively growing, those stomata are wide open. And this means they're using a lot more water, they're photosynthesizing much more, and they're actively growing. If conditions are not perfect, like the light levels go down, or water is less available, or for example, the temperatures get really cold and less water transpires, then the stomata will start to close back up again to conserve water. But as a result, water consumption will go down and photosynthesis will also go down as the stomata close. If you're ever wondering why your plants sometimes use more water or use less water, it all has to do with the stomata and how wide open the stomata are or how closed the stomata are. What you can do is pay attention to the conditions around you. This explains why when you have brighter light, the plant will use more water because those stomata are wider open. And as they open, more water is allowed to escape through the stomata. When you have conditions that are darker, the stomata will sense that and the stomata will begin to close back up again, and water consumption again will go down. This also explains why a plant will use more water when it's hotter out. When it's hotter out and the stomata are open, that water is going to be sucked out and evaporate quicker when it's hotter. When it's colder, it's going to evaporate at a slower rate. So water consumption goes down when it's colder. Also, when you have really dry air, the water is going to evaporate out through the stomata faster. And when the air is more humid, it's not going to evaporate as quickly and water consumption will go down.
So here's a typical interior foliage plant, and it's the underside of the leaves where the stomata are located and where all this stomata action is going on the underside. You can't actually see the stomata with the naked eye. They're quite small and microscopic, but that's where this is going on. And these stomata, remember, are going to open and close based upon the amount of light that's hitting these leaves. So if I move this plant to a higher light location, these stomata will open up wider and this plant will use more water in those conditions. So now I've moved the plant to a highlight area right in a window here, and the stomata are going to start to open up wider. And as that happens, it's going to pull water up and out of this plant faster. It's going to use more water and it's going to transpire more. So the water usage of this plant, this same plant, is going to be a lot higher right here in this window than it was before where it was darker. Also, if it's warmer here or drier, then this water is going to evaporate quicker, and that's going to pull water out of the plant faster. So that's why when it's hotter or drier, the plant will use more water than when it's cooler and darker.
One of the most common questions I get involves leaf spotting and leaf tipping. And oftentimes the root cause of leaf spotting and leaf tipping is water and nutrients not moving well in the plant. In June, we're going to talk about ways to regulate water movement so that water and nutrients can move more effectively and evenly throughout the plant. And this will help prevent tipping and spotting. I hope you found this presentation on stomata helpful in understanding how water and nutrients move throughout the plant. Water is pretty amazing stuff, and without water, plants and people would not be alive. As we wrap this up today, think about your plants, the plants that you're taking care of. and think about the stomata on those plants. How wide open do you think the stomata are on your plants? Think about the environment that they're in. Think about things like light and temperature and humidity. And based upon that, try to guess how wide open or how closed shut the stomata are on your plants. And think about how that affects the water uptake of those plants. How much water are they using based upon their stomata? And finally, think about that in terms of how you water those plants.